115 people were killed, thousands injured. The toll would have been even worse if the quake had occurred 2 hours earlier while the schools were still in session. The city's schools took the heaviest damage of any class of building. Most of the buildings still standing had to be demolished. Though its effect was devastating, the tremor that jolted Long Beach was only of moderate power. Computer technology is now being used to help record and analyze changes in the Earth. Much of the San Andreas Fault is now under close surveillance. It is bugged with a network of ultra-sensitive instruments. Each detects subtle movements and changes in magnetic fields which might precede a quake. Dr. Peter Ward is chief of the Mechanics and Prediction Branch of the National Center for Earthquake Research in Menlo Park, California.
We know that stress is building in California, and that we know that stress will be primarily relieved in a major earthquake. When that earthquake will occur, we're not sure of, but we know that it will occur.
Using the knowledge that certain physical changes occur in the Earth before some tremors, scientists have accurately predicted small, localized earthquakes. A tiltmeter detects tiny variations in the Earth's level. Slight movements are sometimes a signal that an earthquake will take place. Powerful laser beams measure the movements of Earth along the fault line, checking for sudden changes. Much of the San Andreas Fault is highly active. In Central California, about 10 earthquakes are recorded every day. The Mojave Desert, just north of Los Angeles. A striking landscape lies on the center of a little understood and controversial geological event. It has come to be known as the bulge. It is a phenomenon that has preceded some major earthquakes. For 15 years, a vast area along the San Andreas Fault has been forced upward a full 10 inches. It may be a signal of a giant quake to come.
We know that a major catastrophic earthquake is inevitable in California, certainly in the Los Angeles area. We know from detailed studies of the Los Angeles area and what the effects of this earthquake might be. If the earthquake occurs during the day, perhaps 12,000 people will be killed. If it occurs in the middle of the night, maybe only 3,000 people will be killed. But if one dam were to fail, perhaps tens of thousands of people will be killed and hundreds of thousands of people will be homeless.
The threat of earthquakes is much too real, but there may be warnings of a giant quake to come. Not a day passes without earthquakes striking somewhere in the world. Often they are too slight to be felt. Inevitably, however, a giant quake occurs, convulsing with such magnitude, it shakes the entire planet. The port of Valdez, Alaska. It is Good Friday, 1964. The Chena, the first freighter of the spring, has just come in to dock. Standing on deck, two sailors begin taking 8mm movies. They film the people and dogs on the dock below. At 5:36 p.m., the Earth begins to rumble. The sailors hold on and keep filming. Suddenly, the water in Valdez Harbor begins to drain away. Formed 20 miles at sea, a 50-foot tidal wave smashes into Valdez Harbor. Anchorage, Homer, and Seward, jolted with a force equal to thousands of atomic bombs. Tidal tidal waves sweep Kodiak and Cordova. 500,000 square miles feel the effect. Downed power lines explode oil tanks, which blaze uncontrolled. Broken gas mains set houses aflame. In Anchorage, the central business district is all but demolished. Large areas of ground turned liquid during the quake, dropping the streets and buildings as much as 30 feet. The Alaska quake was the largest to strike North America in this century. 114 people were killed. Nearly 5,000 were left homeless. Valdez Harbor was destroyed. Scientists are looking in many directions for new ways to predict violent quakes. Up to 12 billion light years away, like fixed beacons in space, are points of light called quasars. They emit regular bursts of high-frequency radio energy. Radio antennas on opposite sides of the San Andreas Fault receive and measure signals from a quasar. By comparing the arrival times of these signals, minute movements of the Earth's crust can be detected. Subtle changes in the San Andreas Fault now reveal themselves in 3 dimensions. A sudden variation may be an early signal of a forming earthquake.